Okay, so we're going to do the muni bonds here. So what you would be given is what I have here in red. You'd be given this. You would be expected to find the interest payment in the total that's due at each time period. You'd also be given the dated date and the first interest payment date. So now how do you handle this? What we do is we start at the bottom. This bond right here, think of this as 1, 2, 3, 4, 5 separate bonds. This bond is $30 million. It pays 5%, so the interest paid on that bond is $30 million times 5% divided by 2, which is $750,000. So I need to make the $750,000 payment each one of these time periods. And we'll deal with the first interest payment later. But each one of those time periods I need to get $750,000 because the bond will say it pays interest every August and February 1st, commencing August 1st, 2014. So the bond that matures in 2019 makes 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 total payments. Then the interest for the next bond, the one that matures in 2018, that's $25 million times 4.5% divided by 2. That is equal to, I don't have that number in front of me, but if I add 750 plus that amount, it will equal 1,312,500. Let me pause for a second. Okay, so that number is 562,500. So what you have to do is each time here you're paying the 750 all the way starting in 2014. You're paying the $750,000 every 6 months until the maturity of that bond in 2019. We're also paying $562,500 beginning in 2014 until that bond matures in 2018. So we would repeat this process for every bond. The next interest, a little darker, the next interest one would be this, the 20 million times the 4% divided by 2. That one I can figure out will be $400,000. So now this payment right here, that payment right there is $750,000. Well, let me do it like this. That payment would be, I'll color code it for you. The $750,000 for the bond that matures in 2019. The $562,500 for the bond that matures in 2018. And the $400,000 for the bond that matures in 2017, so that should add up to $1,712,500. And you repeat the process 2 more times, and that would give you the interest payments right here. The total column is just the interest payment plus the principal. Okay, so the last thing that's going to be a little, well, not confusing, but the last thing you have to deal with here would be the following. I have the first interest payment date. So in a normal interest period, on August 1st, 2014, I would pay $2,125,000. The reason I would pay that amount is because it would be this bond, $10 million times 3% divided by 2, plus $15 million times 3.5% divided by 2, plus $20 million times 4% divided by 2, plus $25 million times 4.5% divided by 2, plus $30 million times 5% divided by 2. In other words, at this first interest payment, all 5 of these bonds are still alive. They haven't matured yet, so you should pay them the interest that they're due, which is principal times rate divided by 2. However, we divide by 2 because it's a semi-annual pay bond, and there are 360 days in the year. That means there's a 180 days in the coupon period. So there are 180 days from here to here, from here to here, each one of those times, there are 180 days in each one of those periods. But the bonds don't begin, they weren't born in 2014 on February 1st. So how much time is there from 12/10, see if I can say this right, from 12/10/2013, this is the dated date, right here, the dated date. That means this is when the bonds begin to pay interest. Now, let me get some of this stuff cleared off. I'm going to pause real quick. Okay, now it's a little cleaner. These things are born on 12/10/2013. This is when the dated date, that's when they begin to pay interest. The first interest payment is on August 1st, 2014. So that's not 180 days from that date to that. So you should get more than 180 days worth of interest because you've had more than 180 days of the bond being alive. So how many days is it from the dated date to the first interest payment date? The day count formula looks like this. It's 360 days in a year, and the first interest payment is in 2014, and the bonds were born in 2013. So there's a year difference in their birthdays. There are 30 days in a month. The first interest payment is in August. The bonds were born in December. So what you're saying here, you're making the adjustment. This wasn't a full year. You're shortening that time period by 4 months. And then they will pay interest on the 1st, and they were born on the 10th. So when I do that and add this up, that's 231 days. So I get 231 days worth of interest. So that's going to equal my 2,727,083.33. Okay, I tried to do this in one take because I'm in a hurry, so hopefully this makes sense. But basically, to sum up, what you need to do for the muni bonds is I take each one of these bonds and I see when they pay interest and what interest they pay. So the 30 million times 5% divided by 2 is 750,000. I pay that 750 every August and February 1st, beginning August 1st, 2014, with the one exception of the first interest payment where we do something different. This bond that matures in 2018, I pay interest every August and February 1st, beginning in 2014 and ending when it matures February 2018, and that interest payment is 25 million times 4.5 divided by 2. Likewise with this bond, I pay every August and February 1st, beginning in 2014, ending February 2017, and that interest is 20 million times 4% divided by 2. Same for these two bonds, and I'm making a different adjustment with the first interest payment. I have to adjust for the period. It's not going to be exactly 180 days, so how many days is it from the dated date to the first interest payment date? In this case, 231, and that's it. Okay, for effective duration and convexity, so effective duration and convexity, those will be conceptual questions rather than have you work something out. And the concept basically is this: I need to use effective duration and convexity when the bond has an embedded option in it. Otherwise I don't need to. Beyond that, close enough.